લઈ ભાઈ આવી ગયા છે અત્યારે ઓલા આવું તો આકાશબેન જોઈન કરવું હતું લિંક મોકલી આ પ્રદીપ કહેતો હતો એને આવું છે હા
રાખવાનું છે આમાં ચાલુ છે રેકોર્ડિંગ ચાલુ છે એટલે આ હરખું જ રાખવાનું છે એમાં કંઈ એવું નથી કોન્સ્ટન્ટ બંધ કરી દો છે ક્લોઝ કરી નાખું હા ચેક આમાંથી કર્યો આમાં છે આવું જ રાખવાનું છે ખાલી જોજો તો ચાલુ છે ને બરાબર અઠવાડિયું કરી ગયા. આની ઉપર જ આવી ગયો. આપણે સાંભળવું હોય તો ડબલ ભેટ કરીએ છે. નિસર્ગ એવો આપણો હોય.
So, hello, good morning, everyone. Am I audible?
Yes, you are audible.
Yes, so we'll wait for 10 minutes more. Then we will continue for the session.
ક્યાં ભાઈ પટેલ જ હોય એટલે પટેલ જ હોય ને લાગે તેવું આપણા હે ને નીચે રાખી દઈ ગયો ઉપર બીજું બધું નહીં કહ્યું હોય
Sorry guys for keep waiting. We'll start in few minutes. Hello. Sorry guys for keep waiting. We'll start in few minutes.
Okay, no issue.
કર દો નામ બધું મહેશ્વરા નામ જોડે તો ખબર પડે આમ ઓલા એક્સપર્ટ લોગિંગ કુંડિયા આનંદ लोड मत लेना अब उन लोगों को लोड देना है आम रख दो जो हाँ नहीं आओ
Okay.
Okay, so we'll start. Hello, good morning, everyone. I hope you are doing well. So let's start our meetup. Myself, Noel Shripade, along with me, today's our co-host is Amisha Panchal. Let's get hello from Amisha.
Hello, good morning everyone.
Okay, so we both are working as .NET developer in Yudiz Solution Private Limited. On the behalf of our organization, I heartily welcoming and thank you all for joining our meetup. So let me introduce our today's speaker, Ms. Bhavika Sardara. She is working as a .NET developer in Yudiz Solution Private Limited, and Mr. Akhtar Ali Ansari. He is also working as .NET developer in Yudiz Solution Private Limited. We successfully completed our first part of meetup, and was the understanding of microservices with .NET Part 1. If you are not able to join our first part of meetup, then we will share a YouTube link at the end, so you can go through it. And we are back with understanding of microservices Part 2.
Are you guys excited or not?
Yeah, we are super excited.
So, without taking much time, let's start. Today's agenda for our meetup is first, micro first overview of microservices part 1, second, review microservices event bus implementation, third, review microservices project folder structure, fourth, create demo project in microservices architecture, and fifth, question answer. First two topics will be covered by Ms. Bhavika Sardara. So I will hand over this session to Bhavika.
Hello, am I audible to you?
Yes, Bhavika, you are audible.
Yeah, you are audible.
Okay, so as Naval introduced me, I am Bhavika Sadhara, working as a .NET developer at Yudiz Solution. So, without wasting too much time, I would like to speak on the today's agenda. So, in the first, we will discuss about the microservices, uh, basic topics like destinations and communication type and all that we have already discussed in part one. So, starting from the microservices overview of part one. So anyone here who is know or who is already implemented microservice architecture in their project? Anyone here?
No.
Okay, so let's start with the definition of the microservices. So microservice, as the name suggests, is provide us the facility to deploy our services in a small partition. So it's a small, modular, and independently deployable services, and every service will be on the other different pods, and they will communicate with each other, and or we can say that all services are not depend on each other, but on the other hand, we can say that it is rely on each other. In the older days, everyone preferred the monolithical architecture because there were not a facility of the microservice or not awareness of it like that. But nowadays, every developer the first choice becomes the microservice architecture because they have the so many benefits of it. Like here we have the difference of monolithical architecture and microservice architecture. Monolithical architecture provides us the one way of services in which we cannot able to the partitioning of the services. On the other hand, if we are using the microservice architecture in our project, it provides us the facility to partitioning of our services in a small partition, and everything will be independently. So then we have implemented microservices in our project, and if I want to change our technology, framework, or the language, it will be very easy for me because every service will be independently. So if I want to change something, I will change in one service. If it's working properly, then and then I will implement it that particular thing on the every services. And this is the main benefit of the microservice architecture. And we can say that every service will be loosely coupled or independently. So, on the other hand, I have implemented monolithical architecture, then it will not provide us the facility of partitioning the system, right? So everything will be tightly coupled and depend on each other. So if I want to change something, it will be very difficult for me to change everything. So this is the benefit of microservices instead of using the monolithical architecture. So here we can have the question like how that other portable services will communicate with each other. So microservice also provides us the facility to using the gRPC protocol. So let's move on to the gRPC. Before it, anyone here who have the idea regarding the gRPC protocol or the gRPC framework? Anyone here?
No, this new for us.
Okay. If anyone have any question, they can ask me, or even if they have questions, then drop in the chat box as well. So let's move on to gRPC framework. Yes, gRPC is the modern and lightweight communication protocol, and that is the framework that provided by the Google. Yes, this is the provided by the Google, and it's a totally open source, and it's a universal RPC framework that can run on every environment. Google designed the RPC for the best performance and efficiency possible as soon as possible. gRPC provides us the high performance, and we can use gRPC in our microservice architecture because it's a fast work as compared to the JSON-based RESTful API. We can also use the REST API in our microservice architecture, but this is beneficial for us to use the gRPC because it's lightweight as well as fast protocol. So here we have can question that how does the gRPC work? Because every service will be on the different port. So if we are implementing the gRPC in our project, it will first create one proto file and on the client side, and through that path we have to connect this particular proto file to our server side, and through that connection, gRPC will create one stub file, and this is the main flow. Through that, gRPC will work. It will create one generic sub file, or we can say that the proto file. In this proto file, we can pass our one request and response as well. What type of request I want to send and what type of request I want to get, and that will all that define in the one proto file. And let's move on to the why we are using the gRPC because they have their own benefits instead of using the RESTful API. We are using the gRPC because it also provides us the facility to load balancing, tracing our application, health checking of our APIs, application, and authentication as well. So there is so many benefits of gRPC. So we can implement gRPC in our project, and later on we will also view the demo of the project in which we have already implemented gRPC. So let's move on to the next topic. This is the Docker. So anyone here who already implemented their project in Docker or who know that what is Docker? Anyone here?
Yes, I know. Docker
Okay.
is like a content
Yes.
provide like a content management platforming or developing the shaping the running of the application like that.
Yes. Yes. Exactly.
It's very fast we are we are all the content in the Docker, so it's like a user friendly and it's bandwidth friendly like that.
Yes. Exactly. Let's deep into the Docker. Docker is an open source platform that provides us the facility for developing and shipping our project and running as well in the Docker. And as they say, Docker is also very fast, and it will also deploy the fast. So using of Docker with the microservice, it will be more beneficial for us because every service will be differentiated and every service will be separate on their own places. So how to manage all that things and how we can running, shipping, and all that thing in one particular thing, so that we can use the Docker. So Docker will be provide us the facility to separated services and manage them, and also it will provide us the facility if one services will create one issue, then it will not affect on the second thing. So that's why we are using the Docker. And let's move on to the architecture of Docker, so that we will get a deep idea about the Docker, how it is working in all. So this is the architecture of Docker. So in this architecture, we can see that first side we have the client, on the other hand we have the registry. Through that we have the Docker host, and in which we can see that the Docker daemon, containers, and image are there. Okay, so let's start with the client. Client is the one thing that will always every time it will send the request to the Docker host through the command, or we can say that API, or we can say that kind of RESTful APIs as well. So through the command, it will send one request to the Docker host, and on the other hand, Docker will always ready for the listening the request from the client, and it will process on it, and then after it will work on it. So which kind of commands they are using? That is already listed here, like Docker build, pull, and run as well. So through that command, it will be communicate with that particular Docker host, and here is local daemon. We can say that Docker server, and through that it will first of all create one images and containers. So what is images and containers role in this Docker host? So we can say that images are the read-only binary template, or it is used to build a container. On the other hand, it also contains the metadata of the particular container, that what is the needs of containers and capability and all. It's a kind of, we can say that it's a binary template only. But second thing is the container. It will contains run our project, and containers will define by the images. And also we can say that we will give the access in containers that who will run or implement that project particularly. On the other hand, we have the registry that will persist our data and store our project application as well. So in this architecture, anyone have any doubts or something like?
No, please continue.
Yes. Actually, I have a doubt like Docker is like a free platform or like a platform?
Sorry, hello.
Yes, yes. Docker is like a free platform or like a purchase platform, like we
Yes,
will space.
no, it's open source. It's
It's an
open source.
open source. Okay, okay. So it's limitations of the some Dockers, like we will store the like multiple files or like that.
Through that, we can store the multiple files. So it's a not drawback of the Docker.
It's a any one limitations, like you can store the any file.
Everything to have the own that pros and cons. So can be a anyone who know the uh, cons of the Docker. Anyone here? They can share as well. Anyone here? So let's move on to the next, that how they can communicate with each other. So yes, this is the architecture of the microservice communication. Every service will be on the different port as well. So here we can have questions that through that how they can communicate with each other, and how they can send some requests and manage all the things, that is, which kind of events we have to send to which kind of consumer as well. So in this scenario, we can see that it is a simple request response scenario, in which we can see that one as a client, if I'm sending one request to the particular server, it will be server process on it, and then request response to the particular client. This is the simple scenario of the response. So this is the simple, but in the later on architecture, we can see that if I have implemented the distributed layer like message broker, or we can say that the event bus or type of channel that like pub sub channel and as well. So this type of event, if I have implemented in my microservices, then what happens? Then first we can see that the generator is there. It will generate some event or some messages and send it to particular event distributed layer. Through that service, it will be identified that which type of request sent to which type of consumer, right? And this all will be managed by the event bus, and it will be sent to the particular consumer. But how they will work? Let's dip into the event bus, how they can work and how they will identify that particular message to how sent to the particular consumer. So let's dip in that. So before it, I would like to share something like communication type. Like we have two type of communication that we have already seen, like synchronized communication and asynchronized communication. So in the first picture, we can see that is the one-way communication. On the other hand, we have the two-way communication that is provided by the asynchronized communication. But on the first picture, we can see that the synchronized communication provides the one-way communication. So our event bus is provide asynchronous communication. So in which we can share the, send the data. So dive with the synchronized and asynchronous communication. Synchronized communication provides the facility to send the request and response on a one way, and it using the HTTP or the gRPC protocol as well for the returning synchronized response. And we can say that the client sends a request in the particular uh, server, and its server will respond to the particular client. We can say that it's a one-way communication because in between any other request come and send to the particular same server, it will not answering for the same, or we can say that it will block the thread for the particular request response to the server. So it will block the thread, does not allowing other to send the request for the same server. This is the scenario of synchronized communication. But on the other hand, we have the asynchronous communication. It will provide us the facility to two-way communication because as a client, if I'm sending some request to the server, and on the other hand, also one other client sending the request to the particular same server, and server will accept that both requests and working on it, and as well as send to the particular request to the consumer as well. This all will be managed by the asynchronous communication. It will not block the thread and parallelly working for the same scenario. So here we have thing that when we use which communication. So we can use synchronized communication because if you have the operations like simple inquiry that is not changing the state, at that time we can use the synchronized communication, or we can say that we can using the synchronized communication that in if our operation can fail and does not require to complex retrieve mechanism, because the retrieve mechanism will be very complex and it is does not provide by the synchronized communication. So let's move on to the asynchronous communication. When to use asynchronous communication? If your operation will fail and you want to use the retrieve mechanism, then we can use the synchronous communication, and it also can be used when our operation involves multiple services on reacting on it. Or we can say that if I'm using the asynchronous communication, it will also provide us the facility to retrieve if our consumer will not collect the data. So also we are using the async and await in our method as well, as we know it. So this is the communication type of the microservices. It was asynchronous, and second was the synchronized. So uh, let's move on to the message services like PubSub. Here we have so many times we have listened to PubSub. So let's deep dive in the PubSub channel. So what is PubSub? The PubSub the name like publish and subscriber. This is the pattern that which allows us the message sent to one entity to other entity. This is facility of the PubSub. On the other hand, we can see that one entity can be a producer or the publisher. On the other hand, we have the second entity. It can be a consumer or subscriber. On the earlier architecture, we can say that if we have implemented the event bus in our microservice architecture, if, then we can use the PubSub because event bus uh, uh, gives the facility for the PubSub communication. Uh, let's move on to some key features of the PubSub, that how they can identify some particular request and give them to the particular uh, consumer. First of all, we have the message. In the message, it will store the data that we want to send to the particular consumer. And second thing is the topic. Through topic, it will be identified to the particular message. That if my topic is something, and through that topic wise, it will be identified that which subscriber subscribe that particular thing, and I have to send this particular entity to this message. So topic is the one thing that identifies the data. Third one is the subscription. As we already listening, that subscription word is used for the subscribe something. In here we can use the word for which entity subscribe which type of data or receiving messages. Third one is fourth one is publisher. It's also called a producer, or we can say that it is the sender. Or on the other hand, we have the subscriber, or we can say that the receiver of that message particular. So how that work PubSub? So let's deep dive in the PubSub. Here we have the architecture of the PubSub. Um on this picture, on the other, we can say that one hand we have the publisher. There are the three publishers are there. The three publishers send some message to the particular thing, or we can say that we have assumed that we have one message broker services. Through that topic, it will be differentiate the particular message, and through that, it will be sent the particular consumer. This all thing will be managed by the PubSub channel. So it will be very easy if we are implementing the event bus in our microservice architecture, because it will be identify all that particular thing. So topic wise, it will be identify the particular data that that will come from the publisher, and it will be subscriber by it will be consume that particular data. Let's move on the event bus, because event bus provides us so many facilities for the microservices. So let's move on to the event bus. It's a new for everyone. So let's starting from the definition. So event bus is allow us the public style communication between the two microservices, and it also provides us the facility to does not require any component dependency, or even if our two microservices are not aware of each other, then and then it does not matter. It will work on the event bus will manage all the things. So in this architecture, we can see that on one hand we have the microservice one A, on the other hand we have the microservice B and C. So in the first step, we can say that if microservice A will send particular notice, particular event to the event bus, and if we have implemented it in our project, then a particular event will come to event bus. Like if I have changed in our model or entity, then it will be notable event. So this kind of event will come to the event bus, and the PubSub channel will identify through the topic particular data, and through that it will send to the particular services. Like microservice B have already subscribed to the microservice A, or the data of A, then it will be get the notification, and it will be collected data from the event bus. And if does microservice C does not collect the data, and it's if it creates some issues, and we will not affect on it, and it will be work properly. This is the main benefit of implementing event bus in our microservice architecture. So let's move on to the example of event bus with when we can use the event bus. We can use the event bus in our microservice architecture, especially when it does not know our component is uh, every component or every service will be depend on each other or not. Uh, every services here will be not depend on each other. So event bus will be useful at that time. So one services have, or we can say that one component have many reference. Instead of this, if we are implementing the event bus or the microservices, then does not worry about the data. Just use the microservices and event bus. Uh, uh, Send some data to the particular event bus, and event bus you identify the data and send it to the particular subscriber. That all things will be managed by the event bus. Splitting of data and the developing of data, everything will be managed or notified by the event bus to the particular subscriber. This is the benefit of the event bus. Here we have the architecture of the event bus. If we are implementing some microservices with the asynchronized event-driven communication in event bus, then our architecture will be like that. Like in this architecture, we can say that one hand we have the user profile microservices, right? On the other hand, we have the basket microservices and ordering microservices. And we have implemented event bus in our particular uh, project, that using the PubSub channel, or also PubSub channel using the message broker services for the same, like RabbitMQ and Apache Kafka are also available for that, and so many others are message broker services that is available. But if you have implemented something, that it will be work on under the publish subscribe channel. So starting from the user profile microservices, if I have updated something on the my entity, then and if will be updated our database, then it can be said that it is the event that is the notable event, right? This particular notable event will come to the event bus. Publish and subscriber channel will work on it through the topic. It will be identified, and RabbitMQ through it will be also, or we can say that any message broker services will work here, and it will be sent to the particular microservices. And as well as we can also say that it will also collect the database cache, and it will be update the data and collect the data from the event bus. So just send the request, that send the data to the event bus, does not worry about what will happen, because it provides us the facility to manage all that things, and it will be notified by event bus and to the particular consumer, and it will work like that. This is the full architecture of microservices implementation with asynchronous communication. Here we have is using asynchronous communication. So parallelly, it can be a two request come, and event bus will manage all the things, and through that it will be sent particular response as well to the particular consumer as well. So here, anyone have any doubts? Anyone? So let's move on to the RabbitMQ. Uh, in the market, we have so many message broker services like Apache Kafka and RabbitMQ, but we'll go with the RabbitMQ. RabbitMQ is a general purpose message broker that provides us the facility for sending or broke the message and send to the particular consumer. So RabbitMQ using the AMQP protocol for the same, and it deal with the high throughput, and we can use it when we want a transaction like processing, like payment as well. Online payment is very uh, secure. So in that we can use RabbitMQ as well. So we just don't only say that it's a message broker services between two microservices. It's also handles a background job like other, and it's also working as a message broker service. In this architecture, you can see that one have publisher. It will publish, or we can say that any event that come to the uh, exchange, and if any event will publish and come to the exchange, and from there it will be come to the queue, and from queue particular consumer will collect the data or any data from the queue. So it is the work of the RabbitMQ. There is so many benefits of using the RabbitMQ message broker service instead of other message broker service. Um, Through that key features, it will be work like we can say that RabbitMQ is a message broker services. It's using the request and response scenario, and we can also say that it's a point-to-point communication, and RabbitMQ using the PubSub communication pattern for the request send and response get. And on the other hand, we can say that RabbitMQ is a smart broker but term consumer model, because the only facility that provide RabbitMQ providers is that sending the request to the sending the request from the particular broker, but does not delivery of particular consumer will collected or not. This is one kind of limitations of we can say that RabbitMQ. And on the other hand, if we have implementing something other like Apache Kafka, it is the smart broker and smart consumer model. So, but on the other hand, we can say that RabbitMQ is a master platform, because it is supported well. It supports very so many like other Java client libraries, .NET, Ruby, and everything, every other plugin available uh, used by using the RabbitMQ for the communication. On the other hand, we can say that RabbitMQ using both support provides a facility of both synchronized and asynchronized as well communication types, and we can say that it provides a distributed deployment as well, and it provides us the facility for multi-node cluster to cluster federation, in which we can say that it does not rely on the external services. So it will just get notification from the publisher, and from let it will come to the queue, and from there the consumer will be collected data. That will the only work of the RabbitMQ message broker services. And on the other hand, we have, if we are using the Apache Kafka, then it will store their data into their replica as well. So our data will be safe and secure in the Apache Kafka. But we can say that the Apache Kafka is more costly than RabbitMQ, and here we have so many benefits of Apache Kafka as well, and RabbitMQ as well. But if you are talking about the speeding, then RabbitMQ sends a 4,000 to 6,000 message per second. On the other hand, the Apache Kafka will send 1 million message per second. So as well as it's working fast. So anyone who have a question regarding all that things, they can ask me as well, or in chat box as well. Where we will discuss all that particular things. So,
Hello.
yes,
As you
yes,
mentioned, hello. I hope my voice is properly audible for you.
yes, it's audible.
So as you mentioned, the microservice use a gRPC protocol rather than a RESTful API. So how can we say gRPC is more faster than RESTful API? So can you please explain it?
Yes, gRPC is a little bit faster than the RESTful API, because the gRPC is based on the binary protocol, the buffer format. It using this, and on the other hand, we have the if we are using the RESTful API, it is using the text-based format such as like JSON. So compared to the text-based, buffer format will work fast, binary buffer format will work fast. So in which scenario we can say that the gRPC is faster. And also gRPC using the HTTP2 protocol, and RESTful API using HTTP1. So in this comparison, we can say that the gRPC is faster than RESTful API.
Okay, understood.
Okay. So that's it from my side. So let's move on to the demo of the particular thing.
Um, yes, debugging will be difficult or easy from the microservicing. Like some minor issue is pick up. So how to get the code is the like a fart or like that. So we can find out some error or like that. So it's debugging is very hardly or easily from microservices.
From the debugging point of view, we can say that it's a hard kind of, and compared to the others, it's kind.
How to find out any of the error like some numeric error or like some string conversion error. So how to become like a point of how to pick the point like that. So how to resolve or how to recover that. The question is.
Uh, from the audience, any have any idea regarding this type of error finding in the microservice architecture? Anyone?
Hello.
Yes.
Uh,
Can you repeat your question? Am I audible?
yes, yes. Uh, how uh, how to find the error in the microservices? Some like a string conversation or integer conversations.
Okay. The
Like
conversation is
any errors, how to find?
first of all,
Because
if you
debugging is very difficult, I think,
okay, but
microservice.
uh, conversion issue is not the work of it is runtime error. It's a compile time error. So your compiler will work for that. For that, if it's conversion issue or it's a runtime issue, then you can say from a console or you can put your exception handling that off. And debugging has because you have multiple parts like we have API gateways from API gateways to microservices and microservices to microservices if they are connected to each other. So directly you cannot rewrite to from API gateways to the microservice any of the service. So you need to find out which method you have involved and related to that service. You need to put a debugger in your service. So that is the drawback of microservice. Debugging is hard.
Okay. Or we can pass like something like a API, like a string message. So any error runtime or compile time error is generated, so we can respond out my error message. So
If,
uh, can
if it's a
you
compile time method, then your compiler the compiler will generate the error before the build the project. Or if you are deploying it, also it will there you will get the error. Like if you are hosting on Docker, so
Mhm.
before building image, it will show the error. If any of the compiler error, then there will be also possibility there they show line number exact error like if you forget any comma or closing bracket, so that will redirect to the from in service there like you have a service there, so there will write in service there line number that you have this type of error.
Okay, okay. Mhm. Okay, thank you.
Okay, so we'll continue. So thank you, Ms. Bhavika, for an interactive session. I hope you guys will be enjoying this session. Now I request Mr. Akhtar Ali to take a lead for further session.
Hello, hello all. Good morning. As our host introduced me, myself, Sarali Ansari, and I am working as a .NET developer. So, first of all, thanks my co-speaker Bhavika Sadhara, who explained very well microservice overview and revealing the definitions and all definitions. So, I hope you all enjoy that session. Okay, now. Okay, now without taking much more time, I am starting today's remaining session, in which I will cover understanding of Microsoft demo project, which provided by Microsoft folder structure, and after that I have created a demo project related to RabbitMQ. Let me share my. Wait a minute. Okay, let me share my screen. Hope you all are getting my screen.
Yes, yes.
So this it's on is of on container project which is provided by Microsoft for the demo purpose, from where you can learn. So that is the folder structure. First is SRC. In SRC we have API gateway, which where we take our all the requests from the web apps and pass to the microservices, and all the configuration like Eventbus related configurations that are like involved. And after that we have one is for mobile REST APIs, another is for web. And after that we have building blocks. In building blocks we have event buses integration. That all are library projects, just like a pipeline, working like as a pipeline. We settle for some predefined rules for the passing the messages and etc. After that we have a services. Here we create different microservices. These are the microservices like basket, catalog, APIs, identities, and ordering and payment. So these are the gRPC microservices. So let's after that we have a web apps. In a web app we have no rules, no limitations. You can use any type of web app like a web MVC, SQL, like a thing, Angular or a Blazor app. So there is no rule. You can integrate. You will directly integrate the API gateways. That is the REST API. So there is no more limitations for the integration in the web app. You can any type of use a web app. So let's start from the top. In the API gateways, first is envoy folder. In envoy, we have one file. It's known as envoy.yml. Is anyone have idea what is envoy? Hello, am I audible?
No idea.
Yes, you are audible.
Okay, so let me explain it. Envoy file is work as like a traffic controller, and it provides the load balancing for the other requests, and it also work support HTTP2 and gRPC support. So let's come to the file. So first is we define the access log. After that, we have a socket address. From there, it will run, and after that, it's like work like we have a first we define the clusters like it's our web API project, which is maybe our web API or a gRPC API server. So after that, like if any headers contain C, then it will directly redirect to the catalog that request. If any request headers contain O, then it will redirect to the ordering API. So it's work like traffic control. That was the envoy file. So it speed up our request response and also work as load balancing and configuration. After that, we have a mobile BFF swapping, like it's for the HTTP aggregator. These all are the REST APIs. Mobile BFF swapping and web APIs web BFF swapping, those are same. One for is the mobile applications like Xamarin, and second one for the web apps. So it start from the microservices. So here I am first taking the basket API project. This is the gRPC application. So our first step after first we will declare our all the database connectivity and the to do models. And if you are working as an entity working on code first approach, then you will create entity and context, etc. I hope it's the same for the all. It will be REST or a microservice. So I'm not going for that. I'm starting from the proto. It is the main part of the gRPC application. So in first we have a syntax proto 3, that is the version of the proto. After that we have a namespace for that project. You cannot create same namespace as proto file in the single project. After that we package that will generate our file. After that we will declare the services, get basket by ID and update basket ID. And get that is the request of basket request where it will take a ID. And after that we have a response. In response it reply with buyer ID and basket item response, like detail of the item, price, product name, or all the unit price, that all. So once you declared your file, you need to first build your project. Once you build your project, it will generate to gRPC file. Let me see. You can check it from your object folder in object debug .NET and proto. So it will auto generate file for the proto. It generates our compiler. So here is declared first the services which we declared in the proto. After that you have another file basket gRPC. In that it write all the rules for the particular message and the particular variables we declared, like in that we declared a string buyer ID and repeated for the multiple repeats. You can take any integer and double. There is some limitations in proto. It doesn't support all the type of data types. So we need to, if you are want to create any decimal, then you need to first declare here like a string, and you need to convert in your code section. So I hope all are clear with proto. Hello. Is any doubt with the proto file and how it is created and
Anyone have any questions? You can drop it into chat box.
okay. So let me continue. Once you complete your proto section, now we need to, okay, once we completed our proto file and build it, now we need to implement that services, or we can say override that services in the file. So we have one service file. In that we are overriding. First we will inherit that file basket.basket base. It is auto generated with by the compiler, which I saw in object folder. Once you inherit that file, now you need to implement that file. So here get basket by ID, which we declared in the proto file. Okay. Once you declare, then once we declare, then we will take the request, which we also declared in the our proto file. And after that, now here we will write our business logic, or also we can say crude operations related code, which we also write in the REST API. Once we completed our gRPC application, it's known as gRPC server. You can see from the connected services, our proto is connected as a server, basket server. So now it's time to integrate in the REST API related with our API in our API gateways. So first we will provide the URL of that application in our app setting file. Once we write down, then we will need to configure that in the startup file. So here we configuring that URL. Once configured, now it's time to scope that URLs to the particular file. Like here we have a exception interceptor which will work as a pipeline to pass the request to the our microservices. If there is no any error, then it will pass to the microservice. Otherwise, it will take otherwise it will respond with error. Like from there, handle response. If it is okay, then it will respond. Otherwise, it will generate error. So after that, we are providing the basket service to the URL of gRPC basket, which is we declared in the our configure app setting file, JSON file. Once we're done from here, now we need to implement that file, that URLs related to our client. Uh, First, before we need to implement our gRPC client, we need to add client from here. Go to connected services, click on manage connected services. Like here, we connected our gRPC proto, which we declared in the basket applications. We can see the path of the file, services basket API, and proto folder. Inside the proto, we declared basket proto. There was it was like a basket as a client, a server, and here is it like client. If you want to add any new, then we go for the same. If you are connecting with any open API or WCF services, but we are going with gRPC services. So here we will go with the path of that file, like in services, basket. After that, we have a basket API and the proto file. Once you select this file, you need to write on open. Once you open, from here we can select any type of like you work as a client and server both type, or client type or server type, or message only. Once you come sure which type of proto, then after that you can finish the work. Once you finish, it will automatically right here, and we can see also in our CS Pros file. Here is the item group basket.proto, and it's automatically copied to their REST API project. So if you make any changes, then again we need to just build your solution. Automatically it will change from. Okay. So now let's see the implementation of that file, which is in startup. First is iBasket service. So there is the interface. After interface, we will implement it in services. There is the service gRPC service implementation, which we declared in our gRPC server project. First is the method which we declared in interface. After that, we have calling that get basket by ID method, which we declared in basket proto. So once you declared, now it's written our response. Now it's our REST API application. So how directly we can interact with our web app. So for that we have a controller. In basket controller, we need to first create instance of that basket service, which are in the service folder. So once we create an instance of that basket service, now we need to call that get catalog service. Get by ID. Is that clear from this? How gRPC connect? So someone asked you questions like you invoke any request or invoke any action from the web app, which is in our web app, but there is some error. If it's a error like integration level in the API gateway, then it will generate here. Or after you can also can say in our console, like if you are upload it in our Azure, so we can check in container. Otherwise, you can check in Grafana, Google, AWS Lens, etc. Where your ports are integrated deployed. From there you can check runtime error, because local system errors we can see in our local console, but if you deployed it in, then you can check it on the deployed console. Okay. So once integration done, if you call, so if you want to check is it calling our gRPC or not, so first you can debug from here. if it's any issue related to endpoints, like we declared the endpoints and endpoints is wrong, then it will generate. We are unable to listen the port number which you provide in the link. Okay. If it's a problem right from here, so you cannot directly redirect to the, like, if I am clicking here get basket by ID async, so I am going for the basket grpc auto generate file. So for that there is the difficulty of the debugging in microservices. For that we need to, if we are all good from here, then you need to put debugger in your microservices and like this. Then you can check is it working proper or not in that file. You cannot directly come to that file from a aggregator to microservice, any grpc project or microservice project, because it is not directly connected. There is a communication, synchronized communication type, like grpc is a synchronized communication. And someone also asked you how it is fast. So it's fast because it work on http2 protocol, and in a machine readable binary format data passing, so it's a machine easily to readable for machine. In REST API, easy to human readable, and it's working on the HTTP2, so it reduce our network latency. It use all the possibility of network. So this is the file which provided by Microsoft for an example of microservice integration. So anyone have any question from this folder structure? Hello, am I audible?
Yes, you are audible.
Does anyone have any question for folder structure? Okay. So after that we are if you so talk about Docker. So here Docker Compose project. In that we have a Docker viable file. There we register our API project. So will be which will be accessed on the time of deployment of our applications on the any if you are uploading on AWS or Azure or Docker Kubernetes, etc. So that will be read that time file. It's used to deploy our applications. And after that you have an override YAML file. In that we will define the port for the particular project. Like for the SQL data, there is the SQL related port. After that we have basket data project, a basket data database. There is another port. After that we have for the APIs, like identity APIs. For that all the port numbers and all connections. And same is the Docker Compose code file. It will be used in the product at the time of production for the product. Okay. Inside building blocks, first is dev space ports. In that we have some predefined pipelines like for the message handling, like HTTP contest acceptor, etc. HTTP request messages. And after that we have a event bus related project. We have first of all for the event bus pipelines. After that we have for the event bus RabbitMQ class library, like that subscribe, publish, message. There is a predefined, so we can use for in all applications, in our all services, to publish any message. You do not write to again and again. So it's created for the remove the code duplications. And there is one drawback. You cannot write shared project for that in which you have a continuous changes. If you are creating any shared project in which you have a continuous changing, then it will take much time to redeploy your project. Okay. And same for the first one is for RabbitMQ, second one for the Azure web service, that is, and third is the web host. in that we are declaring the orchestra type, that is the also Docker Kubernetes. Kubernetes is the, it is used as like a Docker, but is from the Kubernetes. So any other question from here? Okay. So hello.
Hello.
So it was the folder structure the explanation of provided by the Microsoft. Okay. Now let's see the demo of our RabbitMQ implementation. Hello. Anyone have any question?
Hello.
Yes.
Hello. Can you please explain what is protofile?
Protofile.
Yes.
Okay. So protofile work like as our interface. Like first we declare interface, then it implement it. So same is the protofile. First we declare all our request and our request responses and services which will be implemented in our services. So let us come to the protofile. So first is syntax. That is the version of the proto. After that we have a namespace for that particular project, and after that we have package name. We are providing the package name. After that we are providing the services basket that will generate the basket to base class. And after that we have a two method, get basket by ID and update basket that is. And the request is like a basket request, in which if you are want to get any detail of any product, so you will pass the ID. So there is the one method request ID, and in response it is responding with customer basket response. Like if you once pass the customer ID, then you can say all the baskets of product of the particular customer. So here's the like buyer ID of the customer. After that you have the repeated basket item response. Repeated means that he or she can have multiple products. So there is the repeated for the like work like as loop or list. So any question? I think clear.
Yes.
I think
Thank
you
you
are
for sharing.
okay. So now let's see our RabbitMQ demo project. Sorry, we can't run that project because that will take us much time, and we have a time limitations, and Docker will take much time. So now let's see the RabbitMQ project. So okay, it's already in training. Okay. So first I created a shared model which will be shared in the both, but no changes in that file. As I already said, if you are changes in any type of file, continuous changes, that don't create any shared project or shared file, which will be changes or detect on the deployment time. If you are making any changes in that file, like I have a product created, which is a shared. But if I create making continuous changes and I mentioned it in our service YML file, our Docker file. So it will, if any type of changes, then it will republish or redeploy our both application, manufacturer and sales business, because it's there. So we can create a state. Let's see the first our application. Once I created a RabbitMQ model project, and that inside of I have a one class file, model file. Like in that I have a two field ID and name, which we will publish to the RabbitMQ. Okay. So first project is manufacturer API. In that we have all our data related context and entities, context file and entities, which entities we are going to create it. After that we have a product controller. From that you will provide our CRUD operations. Like this method will first for the get, and it is for the post. But before that, now how it publish the message. So let's see our application, our program file. In program file, I am using here I am using head mass transit. Mass transit is the lightweight of the message like it's work like a lightweight to provide the message publish or queue or any for then it will use in all Revit and Q as well. You can or AWS SNS. So that is that have a two type of method using RabbitMQ using in memory or using Rabbit Azure Bus, which you can implement. So I am using RabbitMQ, so I am taking using RabbitMQ method, and after that you have a host address. It's my local host RabbitMQ local host address. After that you have a username guest and a password guest, which is by default provided by the RabbitMQ. Okay, so once you completed with your control publisher uh, startup configuration, now it's let's do in the controller. So in controller, first I created an instance of the iPublish endpoint, which is a mass transit and RabbitMQ and client class. And once you construct it, now it need to call in post method. Once I just show my data in the database, now I will publishing that ID and name to the particular RabbitMQ that will access by the our sales business project. That's known as a consumer project. So after that, we have a sales business project which will it will consume the request of response of the manufacturer project. In that same first we will go to in program file and where we will just write same, but we will also declare the receive endpoint. So endpoint is our event listener, is queue name, and now we will write create our dependency injection for the product created consumer file. In that file, we will accept the message which published by the manufacturer. In product created consumer, we have a first inherit the iConsumer class, which is a RabbitMQ predefined class. Once you declared it, it will provide the one method, consume method. So we need to its interface. So it's compulsory. We need to inherit a. We need to override that method. We need to sorry. You need to implement that method, consume method. In consume method, we have some one object type consume contest. Inside that, we are providing our model's name, product created model which is created in shared project. Now it's taking the message contest message and we are converting it in our product created ID and name. Once we tag in the ID and name, down now you are saving this data to our sales business project database. So this is our RabbitMQ implementation. Now let's check. So first there is I have created two database, manufacturer and sales business. And in manufacturer we have a first let me clear the database. Okay. So now we can see no records in the database in manufacturer and in sales. So there is also no data in the sales. Now I already run the project. So here I am taking ID, name, cost, and description of the as a request. And now once I submit, let me clear it. We have nothing in response in the product get method, sales business API, and another is manufacturer API. I think I hope I created. Okay, here I put the debugger in consume because we want to see the message is going or not before the consuming. Okay. So once I execute that method, first we can say in our manufacturer API we have a response which okay 200. So that means it's completed his task successfully and it doesn't care is receiver receive the message or not. It just published his message to the RabbitMQ, and we can see in RabbitMQ total hour So by default, the portal is local. Thank you. In that we can see we have one message which is an acknowledged and total one message. Publisher already published at 12:18, but receiver till 12:19. It's not doesn't received by the consumer. We can see in the exchanges message rate and message rate out in product created. After that, you can see in the queue one and acknowledged message. So let me consume that message. So I'm here continuing. Once I continue, now we can see there is zero unacknowledged message and zero total. And in overview, it will go down. It's refreshed in 5 seconds, so it's just take time to refresh the portal. Now you can see now we have a zero message and zero receiver, zero acknowledged message in the queue, and it's received at 12:19 at 40 seconds by the receiver. So now let's check in database. First in our manufacturer database, if I executed one ID one book, cost of the book, and after that description. Now let's in the sales business database. Here is I pass ID and name, so ID one and book. So how is the message passing the data debit MQ? We say that was the implementation of debit MQ. Now if anyone have any question regarding debit MQ integration. Okay, so that's done from my side. If you have any question, the stage is open.
Thank you, Mr. Akhtar Ali, for a wonderful session and giving detailed information about implementation of microservices with demo. Now the stage is open for all. If you want to discuss anything about microservices, then you can share here with us.
It's not like a lecture session, so we can discuss regarding any topic. If you have idea, you can put your input. It will be helpful to us, all of us.
Hey guys, it's not mandatory. Only speakers have to answer. It's open discussion. If anyone have good experience, they can share here.
Okay, so again, I would like to thank you all for joining our meeting and give your valuable time with us.
We believe every meetup makes us closer to our milestone on the path of Explore.NET World. So thank you for being a part of our milestone story.
Thank you. Thank you so much for this awesome meetup.
Yes, so here I'm sharing one feedback form in the chat section. Please give your valuable feedback to us. Okay, so here is the link for the feedback form. Okay, so anyone have any suggestions and ideas, so they can share here with us.
We are waiting for your feedback.
Thank you so much, guys, for a wonderful session.
We are waiting 5 to 10 minutes. Please fill the form. Thank you so much, guys. So, hope you all enjoyed the session and we'll meet soon at the next meetup. Thank you so much.
Okay, thank you so much for joining us. And okay, so we'll ending up the meeting. Thank you again.